Good morning, good afternoon, good evening, everyone, depending on where you are. I'm really excited to do the keynote presentation with Matteo together again for the Pulsar Summit. How time flies. It's my fourth year doing keynote presentation for Pulsar Summit. For people who don't know about me, my name is Sijie, co-founders and CEO of StreamNative, one of the co-creators and PMC member of Pulsar. Prior to StreamNative, I was also one of the co-founders of Streamlio. Before Streamlio, I was working many years at Twitter, leading the messaging and streaming infrastructure there. For people who doesn't know about StreamNative, it is the organizer of Pulsar Summit. It's founded by the creators of Pulsar and is the leading contributors of Pulsar in its ecosystem, including but not limited to KOP, Kafka on Pulsar, Flink, Spark connectors, Function Mesh, Aksha, and many other tools and connectors. We offer StreamNative Cloud as a product. It's an enterprise-grade, fully managed Pulsar services, which can run on StreamNative's cloud environment or your own cloud environment. We have partnered with many software teams worldwide to help them accelerate time to production and manage their Pulsar cluster at scale. As one of the early members of Pulsar, I have seen how this project is grown from an incubating project with a couple of contributors to a top 5 Apache project with more than 600 contributors and widely adopted by tens of thousands of organizations globally. Pulsar started as a distributed pub/sub messaging platform. It was built on top of many years of experience of running multiple previous generation technologies at Yahoo. It was designed with a unified API that supports both messaging queuing and streaming. It's a multi-tenant system with a cloud-native architecture that separates compute from storage. It was deployed globally across 10 plus data centers. This differentiator attract many different developers worldwide as they solve a lot of pain points when they use previous generation of technologies. With more and more developers start to use Pulsar, they build different language clients for Pulsar, so people can use their own favorite language to write their own application using Pulsar. Pulsar is also the first ever streaming data system which introduced the concept of tier storage. So it can use cost-effective cloud-native storage service as its storage layer to store the data for much longer period. With the rise of Lakehouse system, StreamNative also further extend its capability to make Lakehouse system become its tier storage. It's going to be made available as part of StreamNative product offering in the second half of this year. With a cost-effective tier storage layer, Pulsar becomes a perfect data system that is able to support both real-time streaming data and as well as the historical data. It makes Pulsar become a perfect choice for unified batch and stream processing. Adding integration with Flink and Spark take Pulsar's capability into the next level. However, not all the applications require complicated systems like Pulsar and Flink. Pulsar introduced the concept of serverless event processing into its ecosystem. It introduced the concept of Pulsar function, which is a lightweight event processing engine. People can write simple functions to process events as they arrive in Pulsar without bringing in a full-fledged system like Spark or Flink in order to achieve their job. With Pulsar's function engine, we also introduced Pulsar IO API for developing different connectors to connect Pulsar with a broader data ecosystem. So developer can use it as a no-code or low-code platform for building their real-time data pipelines. Lastly, and most excitingly, Pulsar extends its capability to other messaging protocols by adding a protocol handler system. This allows Pulsar add supports for different messaging protocols, including Kafka, MQP, MQTT. It make Pulsar becomes a multi-protocol streaming data platform. With all the efforts from many contributors, committers, and PMC members, Pulsar has grown, became a top 5 Apache Software Foundation project with more than 600 contributors, 10,000 Slack members, and adopted by tens of thousands of organizations globally. This is a snapshot of the companies who are using Pulsar, from MarTech to financial services to IoT manufacturing to retail, e-commerce to gaming and more. Pulsar became part of the modern data stack. With the rise of AI, we have also seen Pulsar being used as part of the AI infrastructure to support use cases like vector databases, data ingestion, fine-tuning your large language model. We are excited about the potentials of Pulsar and the use cases that Pulsar supports. At the same time, we have released Pulsar 3.0, and a huge milestone for Pulsar and StreamNative and its broader ecosystem. With that, I'm going to hand over to our own Matteo to talk about Pulsar and its future. Thank you, everyone.
Good morning, everyone. I will start now different section here, and I will start talking about Pulsar 3.0. So this is a new exciting release, and I will just cover a brief amount of all the changes that went into this release, and just to give you an idea and what changed for Pulsar, the features, and the community. So the first feature to talk about, which is not really a feature, is a long-term support model for Pulsar that we'll be adopting from now on. So what does long-term support mean? We kind of like went through a kind of model where we had a lot of quarterly releases for Pulsar, and it's kind of like have a problem with how big the community has become in the past couple of years, and how many users that be using Pulsar in production for a longer amount of time, and then they don't need to upgrade for new features, but at the same time they can't afford to be left behind in using an older version, which means that there is no support for that version. So there is kind of like this imbalance in which basically it is forcing everyone to keep upgrading, otherwise they'll be left without support on older version. So we kind of want to give a path for a longer support time for releases. At the same time, we want to still have a path for fast innovation, right? We want to keep making a lot of releases every quarter with a lot of features, and want to move fast and do that in a safe manner. The kind of like the model we've been adopting is, and again, is nothing new, is similar to what other big projects in the open source communities have been adopting. Is kind of like these LTS and feature releases. So we have these two different releases, and an LTS release, essentially, it is a channel that is like more stable, because once it's released, only bug fixes will be backported into it. So no new features. So that kind of minimize the risk if you are in this kind of like LTS release to bring up new progressions, new bugs, and an issue down the road. At the same time, we will have feature releases. That means that every quarter we will be making these feature releases with new features and improvements. So the only difference that these feature releases will be supported for a short amount of time. So you can have these very, very quick iteration with new features and getting all the latest and greatest improvements. And the downside is that you have to upgrade more frequently. So everyone can kind of choose its own flavor. If you want to stick with a longer time, fewer releases, fewer risk, or if you want to always get on the latest adoption curve. If you're looking at this model, it's kind of like we've been adopting a model where the the .o release is the LTS. So in this case, we just released 3.0. So 3.0 will be an LTS release. LTS releases will be supported for bug fixes for 24 months, 2 years, and 1 additional year for just for security patches for any CVE that gets open either in the Pulsar code or in dependencies for Pulsar. It will be addressed for a period of up to 3 years. And we're going to have an LTS every 18 months. So every year and a half, there'll be an LTS. So we just released 3.0. In 1.5 years, we will have 4.0 release, which will be the next LTS. So this is like predictable. So this kind of like gives everyone a heads up on what is the roadmap is going to be for new releases, and everyone can plan, both developers and users can plan on which release they want to be in. And for feature releases, we're going to stick with every 3-month release, and we'll be shipping new features. So 3.1 will be a feature release. We will be releasing at the beginning of August, and we'll be carrying new features, and it will be supported for 6 months. So one can decide where to stick with. And you may start with, say, 1 feature release, and then if you don't need any additional feature on top of that, you can just move. Say you may start your Pulsar journey with 3.4, and then you may stuck with want to stick with 4.0 in the next LTS if you don't need any additional feature after that. The other point of the LTS is kind of also give a longer path for upgrade and rollback. I think this is kind of like an often misunderstood feature and guarantee that Pulsar houses have provide. So we always have provide guaranteed live upgrade and rollback between minor versions. What does that mean, live upgrade and rollback? So we always guarantee that you can do a live upgrade with no downtime between any minor versions. So you can go from 2.6 to 2.7, 2.7, 2.8, and so on. Now, the problem with this is that people were, the leapfrogging releases was not guaranteed. In many cases, it would work. In some cases, it might not work. So you might need some configuration updates and so on. So it was not clear the path where you are in. If you are in Pulsar 2.6, can you go to Pulsar 2.11? Maybe yes, maybe not. Maybe there are some changes that you have to apply to configuration. So it's not a clear path for upgrade. We want to extend and formalize better this model such that it will always be guaranteed that you can move from one LTS to the next one. And at the same time, once you go up to one version, you can always go back to the previous version. That means that if you do your upgrade and you see some issues in the new version, you can immediately roll back and then open a bug, and then once the bug is fixed, then you can upgrade again. But you always have the guarantee that once you upgrade, if there is something off, you can just roll back and to a previous version that you know it is working. So with this model now with LTS, we say we can always upgrade up to the next LTS version. So if you are in 3.0, you can go directly to 3.5. That will be guaranteed to work, and then you can go back to 3.0. At the same time, you can go and skip all the feature releases and just go from 3.0 to 4.0, and then again back to 3.0 in case of a rollback. And again, if you are in the mid using a feature release, say 3.1, you can again go directly to 4.0 and then back to 3.1. What it will not work is that if you want to go from say 3.1 to 5.0, that will not be working or not guaranteed to be working. Or if you want to go from 3.1 to 4.3, for example. So, but at least it gives a clear path, and combined to the long amount of time that we support these LTS releases, it will be basically accommodating a lot of more users, and it will be a much smoother schedule for upgrades. Next one is, again, it's not a feature, but it's more an improvements section. So we did a lot of targeted improvements in Pulsar and Bookkeeper around performance, and in particular around performance in cases where you have clusters with many topics, and or when the message batching is either disabled or ineffective for multiple reasons. So if you're spraying your throughput across many topics, it is much more inefficient compared to having a single pipe where you can do all this aggressive batching, compression, and all these standard techniques to improve throughput. In this case, with many topics and no batching, basically the CPU contention becomes the limiting factor. So it is not I/O, it is more on CPU contention. And especially if you are sensitive to latency, then basically you have to tune down, scale up your cluster much more just because of the CPU contention. So there are many changes in Bookkeeper 4.16, and there are many other ideas that didn't make it in time for 3.0 and will be added later on. But I just want to give some brief heads up on where we are and the difference for 3.0 compared to the previous releases. And one example is that, okay, it's a simple example, but this is a single topic. So this is kind of like the use case where Pulsar was already very efficient because this is with batching, and so a single topic, single partition, and we are pushing 100 megabytes per second, and we can see the clear improvements here. I mean, it is not night and day, but you can clearly see that there is like a 0.5 milliseconds improvements overall in the latencies. So and this is the path where Pulsar was already very efficient, and a path where Pulsar already has much better latency than any other system in this case. And where the changes are more impressive, though, is where we are spraying the throughput across many topics. So in this case, it's a 10K topics over 3-node cluster. There's not really much difference between 10K, 50K, 100K at this point, because it just means that the batching is gone. So if you're spraying 100,000 messages per second over 10K topics, basically you have 10 messages per second per topic. So it is really not enough to have batching to play any significant factor at this point. So what is impressive here is that you can clearly see the progression. So the red line was Pulsar 2.10, and the blue one is Pulsar 2.11, and the green one is Pulsar 3.0. So you can clearly see the latency, the 99% latency is around 6 milliseconds compared to before it was around 30 milliseconds. And in Pulsar 2.10 it was around 50 milliseconds. So it's a really good progressions. And again, we hope to bring it even lower in the newer releases, but it's already an impressive improvement in that you can just do by just upgrading to Pulsar 3.0, and you get that for free. Another way to see these is the same same scenario, but now so again 10K topics in a 3-node clusters and measuring the max throughput. So in this case, we almost double the throughput from 220 to 30 to 410 megabytes per second, 410. So again, this is just due to the work we did to improve the contention in Bookkeeper and Pulsar. We'll be writing more extensively about this, and this merits its own blog post with the in-depth analysis on how we came to all these changes and what we can do next. But just to give you an idea on the kind of improvements that you can see just by upgrading to Pulsar 3.0. Another change which is not included in these charts is Bookkeeper with direct I/O. So Bookkeeper has never relied on page cache, but it was just writing on files, and therefore the OS will use page cache for you. Right now with 4.16, we can also bypass the page cache and use direct I/O for writing the entry logger. That means that we can skip the page cache and the double memory copies there, and it is especially relevant if you deploy in containerized environments, because when you put a memory quota on your containers for Bookkeeper, that memory quota gets applied to the page cache. So the OS has to spend a lot of CPU and data cycles just to keep the quota of the page cache. If you don't use page cache, all that work goes away. So we bypass that double copy, and we also don't have to do this. We don't have to get the OS do all this housekeeping for the quotas, which can be very expensive. And around like new features and new improvements, we did a lot of work around the new load balancer. So this is a PIP that has been in the work for many months, and it effectively started with one idea that the old load balancer in Pulsar, it works fine most of the time, and especially considering the Pulsar architecture that is designed for easily move topics from one broker to another. But there were like corner cases in which it was not reacting well to the spiky loads, or that it was taking longer time to converge to a balanced traffic in the cluster, or in some cases it was not reaching a well-balanced scenario, and it was very difficult to understand why. So we kind of like took the approach of restart from scratch, almost from scratch, but the goal is really to have the traffic well balanced in the cluster, even when the load is very spiky. So you can start with topics that jumps up and down, and different topics at different times, and it should reach a well-balanced scenario always. And also we put an accent on how fast can we reach this scenario. And finally, the other consideration here is also to measure and minimize the topic unavailability time during reassignment. So a topic, when it gets moved from broker A to broker B, it will be offline for a very short amount of time, and in hundreds of milliseconds, up to a second. And we want to kind of like make sure that we minimize this time to have these latency bumps in the client to go away. We changed a few implementation the details in this new load balancer, meaning that we don't use Zookeeper anymore to manage the ownership. Instead, we use the Pulsar topic. We also use the Pulsar topic to propagate all the load information, so that each broker can have a very up-to-date and accurate view on the load on every other broker. Before, we had to rate limit all these updates because of Zookeeper. Now we don't have to, so we can really have a very up-to-date information everywhere. The other one is the concept of transferring. Before, we used to unload a topic, and this topic can be reassigned to another broker. Instead, we want to make sure that the unload operation is really a transfer. So the moment we take it out, we already know where this topic is going to be, and that is very important because it allows us to make a lot of further optimization in the transferring, which leads to this follow-up work. So that now that we have this concept of transfer topics, now we want to for next version want to improve and handle a bit more gracefully handover topics. So for example, like we want to avoid any client-based retry logic, because that is the one that introduces latency. So if you close the connection for a client, and then this client will reduce service discovery and reconnect to other brokers, and if it fails, then we'll wait some time and try again. So all this works, but they will take time between these waits. Finally, the multi-arc images. So we have added ARM64 to the Docker images. Again, this is not a feature, but it was a very requested a lot by users because everyone has a Mac with M1, and using Pulsar there was with Docker was really painful with many weird Docker errors. So right now you have native images, so that simplifies the development if you run Pulsar standalone, or if you use Pulsar with test containers. Also, it becomes much easier and faster. And also now you can deploy Pulsar on ARM-based servers. So you can go in AWS and deploy in a ARM-based cluster. And this is just a really tiny brief summary of some of the changes that went in 3.0. I'm not cover all. I will just refer you to the release notes because there is a long list of features and improvements. But this, I think, the most exciting for me, from my perspective. And I also want to give some ideas on things that we are working on and in this next year, and we want to get into the new releases. So just the road ahead a bit. So the first one is Oxia. So Oxia is a open source project that was created by StreamNative, and I will be talking extensively in the last keynote today at 5 p.m. So please join in this keynote. I will just go through why we did Oxia, how, and give you an in-depth view of the system. You can also check out the blog for the that we wrote about the introducing Oxia, and I'll defer all details for the next keynote. And apart from this, we also had put a lot of thoughts on around the metrics in Pulsar in the past year, and we came out with this PIP 264 to enhance OpenTelemetry-based metrics. And the idea here is that the metrics have been growing organically over many years in Pulsar. We have many ways to measure the counters, the rates, and the many different naming conventions. It becomes very difficult to understand what each metric means and so on. And we also have different ways to metrics, like through JSON, through Prometheus. And in some cases, it is not very efficient to take a lot of metrics out. Like if you have topic aggregation or namespace aggregation, and there is no flexible way for configuring granularity for aggregation. So you can either have per namespace or per topic, but what if you want to have, say, just few metrics, say backlog and rate in and rate out per topic, and the rest you will just want to have it per namespace. So we are addressing all these issues in this PIP 264, and the base idea here is that we're going to move in the collection of metrics to use OpenTelemetry API across the board in Pulsar, Bookkeeper, everywhere. And we're going to have an API to change dynamically the aggregation of the metrics. So if you have per topics, per namespace, if you want to open some specific metrics, if you want to filter, all these kind of things. So I would, if you're interested in this, I would urge you to check out the session from Asaf, the future of metrics in the Apache Pulsar at 3:45 today. So it will explain all the reasoning and the changes coming for metrics. And finally, we have also put some thoughts, and we will start thinking a bit more around like improving the service discovery and the session establishment. And there are a few reasons. So as you may have noticed, we've been doing a lot of works around improving Pulsar performance and improving Pulsar experience overall when using many topics. And one of the biggest area that we can do improvements is indeed the service discovery and session establishment. So for service discovery, we're talking about topic lookups. So each Pulsar client needs to know which broker is serving a particular topic. But if your Pulsar client is using many topics, that means that it is making individual calls to for each of these topics. And in many cases, this is redundant because the broker will acquire the ownership in blocks, and we can do much better there, and making a single call and give you all the ownership, for example. And also, like, we don't need to keep asking the brokers. We could have a mechanism for more like push notifications, get the current state, and then get push notifications when the ownership changes. That would be much more efficient. So we're looking into these kind of like areas, and I think that will be improving a lot of the experience and scalability overall. And similar to session service discovery, we can also rethink a bit more on the session establishment. By session establishment, I'm meaning establishing a producer in the broker or a consumer session. Like in this case, if you have if you're trying to create a producer over many topics, you're going to make many calls, and there are many redundant operations, such as like checking the schema or checking the permission and so on. So instead, we should be able to make one single RPC and have these the broker do these operations once, and that again will reduce all the CPU usage and the time to wait for all the session to be established. So I'm stopping here, and there are still many other ideas that are bouncing around, but I really believe that Pulsar 3.0 is really a new chapter in establishing how Pulsar releases are managed, and this kind of set the foundation of the next kind of like model for developers and community around Pulsar. And there are many changes in 3.0. We have a whole number of changes coming up this year for the new releases, and I believe, and I truly believe, that we are really now better positioned with this LTS model to ship these features and improvements in a fast and safe way. So thank you for listening, and I hope you will enjoy all these sessions today. And thank you. Bye.